Most people believe fat burning only happens when you exercise, when your heart rate increases, when you are sweating, when your muscles are actively working. Once the workout ends, many people assume the fat-burning process also stops. And when the night arrives and you go to sleep, it seems logical to believe that metabolism slows down completely. After all, you are no longer moving. But inside your body, something very different begins happening during sleep. While you rest, your body continues using energy. Your brain remains active. Your organs continue performing essential functions. Cells repair tissues that were stressed during the day. And during the deeper stages of sleep, your body releases a powerful hormone that plays a key role in fat metabolism: growth hormone. Growth hormone rises during deep sleep and signals the body to begin mobilizing stored energy. Fat cells respond by breaking apart triglycerides into fatty acids. These fatty acids quietly supply fuel while you sleep. In other words, fat burning does not stop when the day ends. Sometimes it becomes more active. But there is one important condition that determines whether this process happens efficiently: the hormonal environment your body enters before sleep begins. If insulin remains elevated late into the evening, fat cells remain mostly closed. But if insulin declines before sleep, the body becomes much more willing to unlock stored fat during the night. And this is where a small evening habit can quietly change everything. A simple walk after dinner. Walking in the evening helps muscles absorb glucose from the bloodstream. Blood sugar stabilizes, and insulin levels begin declining sooner. When sleep eventually begins, the body enters the night in a metabolic environment that allows fat metabolism to activate more easily. Tonight, we are going to explore what actually happens inside your body when you build a small evening walking habit, and why this simple routine may help burn belly fat while you sleep. Because sometimes the most powerful metabolic changes happen when you are not even awake to notice them. When people struggle with stubborn belly fat, it often feels personal. You may feel like you are doing everything right. You try to eat healthier. You exercise during the day. You pay attention to calories and activity levels. Yet the fat around the stomach seems slow to respond. This can make people believe something is wrong with their metabolism. Some assume their body burns fat slower than others. Others begin thinking their hormones must be completely out of balance. But in most cases, your metabolism is not broken. Your body is simply following biological rules that evolved for survival. For most of human history, food was not always available. There were times of abundance and times of scarcity. Because of this, the body developed systems designed to carefully manage stored energy. Fat is the body's most valuable long-term energy reserve. Inside fat cells, large molecules called triglycerides store enormous amounts of energy that the body can use when food is not available. Because this energy reserve is so important, the body does not release it randomly. Instead, fat metabolism is tightly controlled by hormones. When insulin is high after meals, chunky fat cells receive a signal to store energy and remain closed. When insulin declines and other hormones begin signaling the need for fuel, fat cells become more willing to release stored energy through a process called lipolysis. Sleep hormones also play an important role in this process. During deep sleep, growth hormone rises and encourages fat cells to release fatty acids that the body can use overnight. But whether those fat cells actually release energy depends heavily on the hormonal environment present when sleep begins. If insulin remains elevated late into the evening, fat cells stay locked. If insulin declines before sleep, the body becomes more willing to unlock stored energy during the night. This means the habits you follow in the evening can influence how your metabolism behaves while you sleep. So if belly fat has felt stubborn, it may not be because your metabolism refuses to burn fat. Your body may simply be waiting for the right hormonal signals before unlocking its stored fuel. Many people believe that exercising in the evening is ineffective for fat loss. Some worry that moving at night might slow metabolism. Others believe the body cannot burn fat efficiently late in the day. You may have even heard people say that any calories burned in the evening are somehow too late to matter. Because of this belief, many people avoid evening movement altogether. But metabolism does not operate according to simple clock rules. Your body does not stop managing energy just because the sun goes down. In fact, the hours before sleep are extremely important for setting up how your body will use energy during the night. After dinner, your body begins processing the nutrients from your final meal of the day. Glucose enters the bloodstream, and insulin rises to help move that glucose into cells. This process is necessary for stabilizing blood sugar. But insulin has another powerful effect. It temporarily blocks fat metabolism. When insulin is elevated, fat cells receive a signal to store energy rather than release it. The enzymes responsible for breaking stored fat into fatty acids become less active. As long as insulin remains high, fat cells stay closed. But this state does not last forever. As the body gradually processes glucose from the meal, blood sugar begins declining. When glucose declines, insulin also begins falling. And when insulin falls, the body becomes more willing to release stored fat. The speed at which this transition occurs depends partly on movement. When muscles contract during walking, they absorb glucose from the bloodstream to use as fuel. This process helps lower blood sugar more quickly and reduces the amount of insulin needed. As insulin declines sooner, the body enters the late evening with a very different hormonal environment. And this environment determines how your metabolism behaves once sleep begins. So the idea that evening movement cannot influence fat metabolism is not accurate. What matters most is not simply the time of day. What matters is the hormonal environment your body enters before sleep. And a gentle evening walk may help create the conditions that allow nighttime fat metabolism to occur. If there is one hormone that most strongly determines whether fat burning can occur before sleep, it is insulin. Insulin plays a vital role in keeping your metabolism balanced. Whenever you eat, especially meals containing carbohydrates, glucose enters the bloodstream. In response, the pancreas releases insulin to help move that glucose into muscle cells, liver cells, and other tissues. This process prevents blood sugar from rising too high and allows the body to distribute incoming energy efficiently. But insulin also carries another important message. When insulin levels are elevated, fat cells receive a signal to store energy and remain closed. Inside fat cells, energy is stored in the form of triglycerides. The enzymes responsible for breaking these triglycerides into fatty acids remain mostly inactive when insulin is present. This means the process called lipolysis, the release of stored fat, is suppressed. As long as insulin remains elevated, fat cells hold tightly to their stored fuel. From the body's perspective, this is logical. If new energy has recently arrived from food, there is no need to access long-term reserves. The body simply uses the glucose that is already available. But problems arise when insulin stays elevated too late into the evening. If someone eats dinner and then spends several hours sitting still, the body processes glucose slowly. Blood sugar can remain slightly elevated for longer, and insulin continues circulating in the bloodstream. When bedtime arrives under these conditions, fat cells remain mostly closed. Even though growth hormone rises during deep sleep and encourages the body to release stored energy, insulin is still acting like a lock on the door of fat metabolism. This is where evening walking can change the story. When you take a gentle walk after dinner, your muscles begin using glucose for energy. Muscle contractions pull glucose out of the bloodstream, even without requiring large amounts of insulin. As glucose levels decline, insulin begins falling sooner. By the time you go to sleep, the body may enter the night with insulin already declining, removing the lock that was preventing fat cells from releasing stored energy. Now imagine two different evenings. In the first evening, someone finishes dinner and sits down for the rest of the night. The television turns on, the body relaxes, and very little movement happens for the next few hours. Inside the body, digestion begins working. Glucose from the meal enters the bloodstream. Blood sugar rises, and insulin is released to move that glucose into cells. Because the muscles are mostly inactive, glucose is absorbed more slowly. Blood sugar stays elevated longer than necessary. Insulin continues circulating in the bloodstream while the body gradually processes the meal. Hours pass. Eventually, bedtime arrives. When this person falls asleep, the body enters the early stages of sleep, then slowly moves into deeper stages. During deep sleep, growth hormone rises. This hormone encourages fat cells to release stored energy by activating lipolysis. But insulin is still present in the bloodstream, and insulin acts like a lock on fat cells. So even though the body has entered deep sleep, fat cells remain mostly closed. The body continues relying primarily on glucose and glycogen for energy. Now imagine a second evening. Dinner ends, but instead of sitting immediately, this person steps outside for a gentle walk. The pace is relaxed. Nothing intense, just steady movement. Inside the body, something important begins happening. As the muscles begin contracting during walking, they start pulling glucose from the bloodstream to use as fuel. This process does not rely entirely on insulin. Muscle contractions themselves help move glucose into muscle cells. As glucose leaves the bloodstream, blood sugar stabilizes more quickly. Because blood sugar is declining, insulin no longer needs to remain elevated. So insulin begins falling sooner. By the time the walk ends, blood sugar is steadier and insulin levels are already declining. Later that night, when sleep begins, the hormonal environment inside the body is completely different. Growth hormone rises during deep sleep. Fat cells receive signals encouraging lipolysis. Triglycerides inside fat cells begin breaking apart into fatty acids. Those fatty acids enter the bloodstream and quietly supply energy throughout the night while the body rests. From the outside, both evenings appear calm and ordinary. But inside the body, the metabolic story is completely different. One evening keeps fat cells closed. The other prepares the body to unlock stored fat during sleep. And the difference between the two is simply a short walk before the night begins. For many people, the idea of walking in the evening does not always sound appealing. After a long day of work, responsibilities, and mental fatigue, the body often craves rest. Sitting down on the couch or lying down may feel far more attractive than going outside for a walk. Sometimes the first few minutes of an evening walk can even feel slightly uncomfortable. The legs may feel heavy. The body may feel slower than it did earlier in the day. Breathing may feel deeper as the body shifts from a sedentary state into movement. This feeling can make people believe their body is too tired to move at night. But this short period of discomfort is simply the body transitioning between metabolic states. During the evening, especially after dinner, The body has already spent hours working, moving, and processing energy. When someone sits still for a long period after eating, circulation slows slightly and muscles remain inactive. When walking begins, several systems must reactivate at once. Blood flow increases to the muscles. Oxygen delivery improves. The heart rate rises slightly to support movement. At the same time, muscles begin demanding energy. Glucose circulating in the bloodstream becomes the most immediate fuel source. As muscles begin absorbing this glucose, blood sugar levels start stabilizing and insulin gradually begins to decline. During the first few minutes, the body is still adjusting its breathing rhythm, circulation, and fuel use. But after several minutes of steady walking, something usually changes. The body warms up, muscles loosen. Breathing becomes more comfortable and rhythmic. The initial heaviness fades and movement begins to feel natural. Instead of feeling like effort, the walk often becomes relaxing. Circulation improves, the nervous system begins calming down, and the body gradually shifts toward a more balanced evening state. What started as slight tiredness becomes gentle movement that prepares the body for rest. And inside the body, the metabolic signals that support nighttime fat metabolism have already begun shifting. When a short evening walk becomes something you repeat every day, your body does not continue responding the same way forever. At first, the walk simply helps your muscles absorb glucose from the bloodstream and encourages insulin levels to decline before sleep. But as this habit repeats night after night, your metabolism begins adapting to the pattern. The first changes often appear in how your muscles manage glucose. Muscle cells become more sensitive to insulin, which means glucose can enter muscle cells more easily after meals. When this happens, blood sugar stabilizes faster, and insulin does not need to remain elevated for as long. Over time, this improves what scientists call insulin sensitivity. With better insulin sensitivity, the body can move glucose into cells more efficiently, which helps insulin levels decline sooner after dinner. And when insulin declines earlier in the evening, fat cells are no longer locked in storage mode when sleep begins. At the same time, changes begin occurring inside muscle cells themselves. Inside each muscle cell are structures called mitochondria. These tiny organelles act as energy factories that convert fuel into usable energy. When muscles regularly receive energy demands from walking, the body responds by increasing the number of mitochondria inside muscle cells. This process is known as mitochondrial biogenesis. With more mitochondria available, muscles become better at using both glucose and fatty acids as fuel. Another important adaptation happens inside fat cells. When insulin levels decline more consistently before sleep, the enzymes responsible for lipolysis become more responsive to hormonal signals. During deep sleep, when growth hormone rises, fat cells begin releasing fatty acids more efficiently. Over time, this repeated pattern improves something known as metabolic flexibility. Metabolic flexibility is the body's ability to switch smoothly between different fuel sources, depending on what energy is needed. When food is available, the body uses glucose. When the body enters sleep and energy must come from stored reserves, fat metabolism becomes more active. A simple evening walking habit helps train this metabolic rhythm. When a simple evening walking habit becomes part of your daily routine, the benefits often extend far beyond those few minutes of movement. One of the first noticeable changes appears in how your body manages blood sugar after dinner. Because your muscles absorb glucose during walking, blood sugar levels tend to stabilize faster. This allows insulin levels to decline sooner before sleep begins. When insulin falls earlier in the evening, fat cells become more willing to release stored energy during the night. During deep sleep, growth hormone rises and encourages lipolysis, the process where triglycerides inside fat cells are broken apart into fatty acids. These fatty acids quietly supply energy while your body rests. Over time, this nightly pattern may help reduce visceral fat, the deeper belly fat that surrounds internal organs and plays a major role in metabolic health. Another benefit appears in sleep quality itself. Gentle evening movement improves circulation and helps the nervous system transition gradually from the activity of the day into the calm state needed for sleep. Many people notice that after a short evening walk, their body feels more relaxed before bedtime. Sleep may begin more easily, and the body may move more smoothly into deeper sleep stages where important hormonal processes occur. Understanding this also removes one of the biggest fears people have about fat loss. Many people believe fat burning only happens during intense workouts. They imagine the body must be pushed to extreme limits in order to lose belly fat. But the body often responds best to something much simpler: consistent signals. A short evening walk is not extreme. It does not require a gym, equipment, or intense effort. But it can send a signal to your metabolism that helps prepare the body for nighttime fat metabolism. When people understand this, their identity begins to shift. Instead of seeing themselves as someone constantly struggling with their metabolism, they begin to see themselves as someone working with their body's natural rhythms. The body was never refusing to burn fat. It was simply waiting for the right signals. Now imagine yourself several months from now. The evening walk has become automatic. After dinner, you step outside for a few minutes of gentle movement. Your sleep feels deeper. Your energy during the day feels more stable. Your metabolism has become more flexible, and the belly fat that once seemed stubborn is slowly being used as fuel during the night while your body rests. None of this required extreme workouts. It only required a small habit repeated consistently. The human body evolved to respond to rhythm: movement during the day, rest during the night. And sometimes the metabolic changes that matter most begin with a simple walk before sleep.